So 18th July, discussion about assignment 1. Did anyone have a look at the assignment?
I took a glance at it and it seemed pretty simple enough. Like some of them were pretty simple.
Oh, good. Very good.
Yeah, 1 and 3 was very easy.
Okay, good. Awesome. All right. So let's, I'll also mention that on Slack. And okay, so let's start with some questions. Do we have some questions from previous time?
No, sir. Not yet.
All right. Okay, so let me start up the lecture notes. Anyone else? Okay, so today we are going to talk about an important idea in angular momentum, the idea of addition of angular momentum. Okay, so today's topic is the addition of angular momentum. And this is an important topic both from a physical point of view as well as a mathematical point of view, because physically we are always dealing with systems which have smaller subsystems which have spin or orbital angular momentum, or a combination of both. And therefore the combined system, we have to deal with how these angular momenta add. And from a mathematical point of view, we will see that it brings the idea of Hilbert space, linear combination, some ideas from group theory, although we shall not use group theory explicitly, into focus. Okay, so as usual, let's start with a small discussion about classical case. So suppose that classically we have two gyroscopes. We have, say, two gyroscopes, meaning that they have some well-defined angular momenta. So in a, say, box. So the box is going to have a total angular momentum, right? Have a total angular momentum. But this angular momentum will depend on both the the magnitude and the orientations of the gyroscopes. Do you agree?
Yes, sir.
Sorry?
Yes, sir. Yeah.
Okay. So, I mean, if you haven't seen a box with, with angular momentum, if I give you a black box and I tell you that if, whether, this has angular momentum or not, so you don't know what's inside, what do you think? Would you be able to tell?
No. I wouldn't be able to tell.
Who was that, Shujash?
Me.
Yeah. Okay. Anyone else?
Sir, could you repeat your question?
The question. So the question is, can I repeat the question? Then, is that you, Rahul?
Oh, sorry.
Yeah. Let me repeat the question and then, you can answer. The question is, suppose I give you a box in which there is a spinning gyroscope, and therefore the gyroscope has some angular momentum, and I give you the closed box, and we are assuming that the gyroscope is attached in such a way that it's not gonna, it's not going to be like, it's not going to be moving around from its point of rotation. And I give you the box, and it's a black box. You don't know what's inside. Is there a way for you to determine whether or not it has an angular momentum inside? And Shujar said no. So somebody said no. So let's say yes and no, okay? Somebody said no. Any yeses?
There was this YouTube video I saw on like a self-balancing box that uses a gyroscope inside. So like when the gyroscope has some angular momentum, like depending on the direction of that, the box would be made to balance on its corners and even the vertices. Like, are you asking something like that?
I'm asking a question which is related to the YouTube video you saw. Based on that, you have to give me an answer.
Yes. So if that's the case, then yes, it
Okay.
can, we can determine
So
it.
one yes, one no. Who else? There are 6 students in this class. What you can do is if you are shy, then use the back channel chat to say yes or no, okay? The back channel chat has been posted on the Slack. On Slack.
Sir, sorry, I came a bit late, so can you repeat the question?
Okay, the question is, suppose we have a gyroscope with non-zero angular momentum inside a black box, and the point of the gyroscope where it's rotating is fixed in such a way that the gyroscope is not going to jostle around if you move the box or something. So it's going to keep rotating. Now, it's a black box, you don't know what's inside. Can you do an experiment to determine whether or not there's an angular momentum present inside the box? Yes or no? We have one yes, one no. So 50-50. Internet is এখন পর্যন্ত it's 50-50. So Nahi,
No.
কোন দিকে যাবা? Okay. Who said okay? Wajia has said no, right? So
Sir, I said no.
okay. So that's Moon said no. Okay.
Sir, now I'm going to say that I believe it's possible. And it's
Who is
Wajia
this?
speaking. It's Wajia speaking.
Wajia?
Yeah. I believe it is possible.
You believe it is possible. So that's a yes, right? Okay. So far 50-50. Nahi, you get the deciding vote.
Yes, yes.
Okay, now he says yes. So we get 3-2. Okay, good. So the correct answer is yes. Because, you have some system. It's a box. You cannot see what's inside. Okay? But the thing is that the system, because it's an angular momentum.
সিস্টেমে তো অ্যাঙ্গুলার মোমেন্টাম থাকবে পুরো
Exactly.
সিস্টেমটা।
So
এখন
it
আমি
has
দড়ি দিয়ে বেঁধে টেঁধে ইয়ে করতে পারি এটাকে
Right.
ঝুলাই টুলে।
So this has an angular momentum I omega in that direction, right? Now what you can do is that you can apply a torque to it. You can apply force to it. And if you apply the force, in the correct direction, what will happen is that, it's going to have, just as you have because it has a moment of inertia, it's going to have, resistance towards the change of its, moment, of its angular momentum, right? Because just as, F is equals to ma, when we apply force, the acceleration, it changes its velocity. Similarly, when we apply a torque, it changes its angular velocity, which is what is angular velocity? I is d omega by dt, right? So dt, and therefore you can multiply I omega is the angular momentum, right? dj by dt, right? So, the fact that you actually have to apply a torque, and you will feel the torque in your hand, right? So it's a good way of doing this is that do any of you have like a handheld vacuum cleaner? So it looks something like this. It looks like a gun, but there's a suction, okay, and there is some bag where it stores the dust, and inside there is some kind of a fan. So it can have some it can be charged, or it can be wired to the wall socket. And if you turn this on, what will happen is that the fan will start rotating, and therefore you will have some sort of angular momentum in that direction. So and the fan is rotating either that direction or that direction. And so the rotating fan will basically be sucking in the dust through here, right? That is the idea. But now if you then want to, if for example you want to now rotate this thing in that direction, then what will happen is that you have an angular momentum in that direction, and you want to rotate that angular momentum over there. So you want something like this. So if you thought that the angular momentum was not detectable, then you would not have any problem doing this motion. But from the point of view, we see that for this to be possible, you basically have to apply a torque. I forget my mechanics, something like in this direction, right? Now, is that correct?
I'm not sure. No, maybe not.
Yeah, let's see. So torque is a vector, and
So the torque has to be in the direction of the change of angular momentum. So it should be perpendicular to the
right,
red line you drew.
Yeah. So yeah, it's a force. So yeah, so the torque should be in that direction, right? Yeah. So the torque should be in that direction, and because what is torque? Torque is force cross the lever arm, or the other way around, right? I think there's a minus sign or something. Okay, so now the point from which you are rotating is this point, right? And you want to apply, and so this is going to be, roughly speaking, this is going to be R. So if your torque is going to be in that direction, and your R is in that direction, then you have to apply. So they make a plane, right? So you have to apply a force in a direction. The force that is going to help you is going to be in that direction, in that or that, up to a plus or minus sign, right? So this is very counterintuitive. You will find that if you try to rotate this, this vacuum cleaner, you're in that way that your hand will twist in a direction which you did not expect. It'll twist in this direction or this direction, okay? Because there has to be a force in the, in that direction for you to be able to do this motion. And by that, you will realize that this object has an angular momentum. Of course, this is making a sound, so we know how it's made, what it's made out of. But this is essentially a box, right? Because have you ever this is usually inside some we can't really see it, right? So the similar thing will happen here. Okay, so this is this is a demonstration I used to do when I was in the US and I was teaching Physics 101. I used to have a very nice handheld vacuum cleaner that I used to use to clean my car. So I used to take it to class and show it. Okay, so I encourage you to go on YouTube and look at videos like that.
There's a Veritasium video called Anti-Gravity Wheel that talks about this exact phenomenon.
Yeah. That's a very good video. That's a I know. Yeah. This is basically how it's easier, or it is seemingly easier to hold a very heavy object while it's spinning than when it is not heavy, when it is not spinning, right, Rahul?
Yes, it was that.
So Veritasium is possibly one of the best channels on YouTube, and not just for physics and math, but also for statistics, the nature of truth, scientific method. And I just love this guy. He is very, very good. I mean, I think he has a undergraduate in physics and a PhD in physics education or something like that.